Okay. Hello, everybody. My name is Eleftherios Trivizakis. I represent the Foundation for Research and Technology Hellas in Crete, and I will present you a deep learning-based model for detecting Greek locations and landmarks. And I'm going to compare it with our previous work, which is a classification-based model for the same task. And we're going to see the benefits of supervised detection versus a weakly supervised classification with soft labels. So what is this study all about? Is a nationally funded program that many partners are contributing. So we are trying to build a platform for audiovisual producers to be able to perform location scouting, which is a task for audiovisual production in Greece with Greek locations. So the platform is called Look Me Platform. I'm going to present you now a little bit our partners. We have the National Center for Audiovisual Media and Communication in Greece, which funds productions from all over the world and Greek productions in Greece. We have a White Fox, which is a private sector company that specializes in audiovisual production, and some other partners that help us develop the platform and exploit it after this research project is finished. So the LookMe platform incorporates several machine learning models such as NLP for natural language processing. We have created an ontology-based search engine, which we are combining the expertise of the domain experts, such as the partners, and of course we are developing several deep learning models for image analysis, and of course we are combining those in order to have a smart engine for the producers to be able to extract more information from images and present better results for the location scouting process. So why pursue this project and why did it fund it? Because Greek economy is dependent on tourism. So we have evidence from the literature at the right here that audiovisual productions in movies or video clips for creatives help boost the tourists, the people that travel across landmarks that are related to movies. For example, there is this hotel that just a scene was filmed there, and you can see that the author claims that this hotel had 50% increase over 3 years for this, for just a single movie. So our study uses several YOLO, you look only once models. We have our custom data set with 10,000 images, but for image analysis, we use a smaller subset with better annotations. These annotations are called bounding boxes, and also these images are aerial images and ground level images. So the classification task is very good at ground level images, but when you are present an aerial image which has a wider field of view, there is where the classification model struggles, and why we are proposing the detection-based model. We are using the best practices by using unseen testing sets for the training of the model. We are using several variations of the YOLO 5 and YOLO 8 model. And of course, we are performing a qualitative evaluation along with the trivial quantitative evaluation, because as we will see, the quantitative evaluation of this model are not sufficient to provide us with the best model. You can see here at the left the baseline pre-trained model that we used for adapting the new model to our data set. You can see here the performance. This is the mean average precision. And you can see that the best, you cannot actually say which model is the best. You can see here our best model has 0.62 mean average precision, but you can see the second best has 0.59, so less than 3% difference in performance. We also applied an ablation study because we wanted to study the number of samples, the impact of the number of samples per class. So we have one model that can predict 13 classes, and then one model that can predict 6 classes. And as we can see, the top part of these two figures, I don't know if you can see them very well. So we have the precision recall curve for the 13th class, and we can observe here that many classes actually falls below the mean precision recall curve. So as we reduced the number of classes, but we increased the quality of data, we can see that the model actually performs significantly better. You can see the 13 class model has 0.48 F1 score, and we can see the 6 class model that has 0.61 F1 score. So that's why we are performing the qualitative analysis, because in terms of quantitative analysis, we cannot actually say which model is the best. But if we can see here, in this figure, we have, no, wait, I cannot move the, okay, thank you. Yeah. So we can see in this figure, I think this is the problem. Yeah, thank you. Yeah. So we can see in this figure, the YOLO V5 model, the predictions of YOLO V5 model versus the predictions of YOLO V8 model, the proposed one. And as you can see, but you cannot read, of course, the text, the YOLO V5 in many cases does not make any prediction compared to the YOLO V6, V8 model. And in many cases, it actually, the bounding box is not accurate, and it's not even the same class. So you have here ancient theater, because in the images of the ancient theaters there are people, so every time it sees people, it thinks that it's ancient theater. Or you can see here it correctly predicted the class, but the bounding box is is smaller than the actual ground truth. And also you can see in the YOLO V8 model, it actually predicts the mountain also, that the YOLO V5 model lags. And here you can see that it doesn't make any prediction. Also, the YOLO V8 model had the advantage that it can learn actually subclass representation. So we had aerial shots and ground level shots. So you can see here that successfully can detect an olive grove from above, and successfully can detect an olive grove from a close-up image. And also the number of instances is increased compared to the other models. Same here with a vineyard, and also it can also predict different other objects in the image. So in our previous study, we just explored the classification model because the first iteration of the dataset had only ground level shots. So you can see here the attention maps of the classification model, which means what the model thinks the class windmill represents in the image. And you can juxtaposition it with the detection, the bounding boxes, that actually can differentiate between different instances of the class windmill. You can also see here that the classification model cannot detect, of course, other classes like a mountain, which is the case for the detection model. And this is a very interesting sample because the actually human annotators that made the annotation with the bounding boxes did not see the ruins here. So we didn't have this label, but the model actually predicted the ruins, as it also predicted the temple here. And a very interesting part is here where the church is. You can see the churches. So the model just focuses in one area of the object and not the entire object which is the case for the detection model, the highly supervised model versus the weakly supervised with soft labels, right? So in conclusion, you can see that even though the difference between the YOLO V5 and the YOLO V8 was 3% in terms of mean accuracy precision, the actually qualitative results was completely different, with entire classes missing from the YOLO V5. And also we find out that the YOLO V8 was able to differentiate between subclasses in its inner representation. And of course, the main limitations was the size of the dataset, which was very small. That's why we use transfer learning, and the annotation with the bounding box. The process was very challenging. We had many iterations of that process with many different annotators, and still we couldn't. We have a lot of noise in the dataset. So that's it about the project. So if you have any question, we'll gladly answer it. Yep.
Yes, thank you for your presentation. Have you tried to use your model to maybe predict any other ancient building, not only Greek?
No. This project, we had only access to Greek monuments. Okay. So we didn't have access to any other type of civilization, but I have to say that in our data set we had ancient tables versus the Parthenon here, and the model actually was able to differentiate between these two. So I guess if we introduce more samples from different monuments, the model will be able, despite being so similar, to differentiate among these different monuments. Okay. So